Hello! This video is part of the Introduction to PLCs. And in this particular video, we're going to look at analog calculations. We'll be looking at 0 to 10 volts and 4 to 20 milliamps outputs from an analog device. And we'll be looking at range, span, and how to calculate the output values based on our range and span. So let's get started. When it comes to analog I/O or input-output devices, there are two main types of signals. The first type is voltage, where the I/O device will put out a 0 to 10 volt output. Now, I'm saying the output from the transducer or the device, but that could also be the output from the device can be an input to the PLC. Since it's 0 to 10 volts, we say it has a span of 10 volts. We'll get into a broader definition or a clearer definition of span in the next slide. Basically, you have a lower range limit, or 0% of 0 volts, and your 100% or your upper range limit is 10 volts. And this is what gives you your span of 10 volts. Another type of analog I/O is current. And the standard for current is 4 to 20 milliamps. So your 0 point, or your lower range limit, is actually 4 milliamps, where you have a positive signal of 4 milliamps or less to actually indicate 0%. And to indicate a upper range limit of 100%, well, that would be a maximum of 20 milliamps. A current signal gives you a much cleaner, more positive signal, because sometimes if you lose some signal, are you really at 0? Whereas anything between 0 milliamps up to 4 milliamps is actually considered a 0% signal. So this gives us actual span of 16 milliamps, because there's a difference between 4 to 20 of 16. So the two main types of analog I/Os, voltage, 0 to 10 volts, and current of 4 to 20 milliamps. These tend to be the standards. There are some exceptions to the rule. So let's take a look at an example, so we can get a better understanding of range and span. Here we have a simple little grain silo. Now, this is not to scale, so as we add measurements, don't worry about it actually being accurate. At the top, we have a radar level transducer. Basically, what it does is it sends a signal down, and as the signal reflects off the surface of whatever is in the vessel, it lets the PLC know how full is the silo. At the bottom, we have an outfeed tube where the grain exits the silo. For this example, the outfeed tube is actually laying on the ground. So we'll take all our measurements from the ground and we'll say that the ground is at 0 centimeters, because it's where we're starting our measurements. The height of the outfeed tube is an offset. So above the outfeed tube is where we actually start calculating how full is our silo. So when our silo is empty, we're at our lower range limit. We do not include the amount of material that's in the outfeed tube. Now the radar level transducer may be able to see the bottom of the outfeed tube, so we'll disallow that. And as we add grain to the silo, we can reach our maximum value, or 100% full, and we call this our upper range limit. The distance between the ground and our lower range limit is what we refer to as our offset. And for this example, we'll use 30 centimeters. A 100% full we'll use an example of 400 centimeters or 4 meters. So our overall range between 100% full and 0% empty, our upper range limit and our lower range limit, is between 400 centimeters and 30 centimeters. So that's our range, 30 centimeters to 400 centimeters, because of the offset of the outfeed tube. This distance between our upper range limit and our lower range limit is what we refer to as our span. And when you take the difference of the 400 centimeters and the 30 centimeter offset, the span of 100% full to 0% empty is 370 centimeters in our example. So I hope that gives you a better understanding of the terms range and span, our upper range limit and our lower range limit. And again, this gives us a span for our example that we're going to use today of 370 centimeters. So let's look at calculating some values as we add grain to our silo. So here again is our empty grain silo. Our outfeed tube or just discharge tube is at 0 centimeters or at ground level. Our lower range limit is at an offset of 30 centimeters from the ground. And 100% full is at 4 meters above ground. And this would be our upper range limit. How much can our vessel hold? Well, that's our span. Between 0% and 100%, we have 370 centimeters worth of distance. So let's add some grain to our silo. And let's say the level of our grain reaches a set point of 150 centimeters. So what is our percentage fill for our silo? Because this will determine how much of our 0 to 10 volts and our 4 to 20 milliamp signal we send to our PLC. Well, we have to calculate what percentage the 150 centimeters is of our silo storage. So our percent output, what we have to do is we have to take our set point of 150 centimeters and remove the offset of the 30 centimeters of our lower range limit. And then figure out what percentage of the remainder of that is with respects to our span. So 150 centimeters, take away our 30 centimeters offset, gives us 120 centimeters. 120 centimeters over 370, well, that gives us approximately 32.43%. So our grain silo is 32.43% full. Now, if we were sending out a voltage signal of 0 to 10 volts, then all we have to do is look at 32.43% of 10 volts, which means the output from the transducer to the input of the PLC would be 3.243 volts. Again, how specific that voltage is depends on how sensitive the input is and how sensitive the output of the transducer is. But what if we were looking at current? We have a 4 to 20 milliamp output from the transducer. Well, that current has a span of 16 milliamps because there's a 16 milliamp gap between the start of 4, which is 0, to 20, which is our maximum, or 100%. So we take our 32.4% and multiply that by our span of 16 milliamps. Then we got to add our 4 milliamp offset back into that, which, when we do that operation, our transducer would be sending a signal of 9.189 milliamps, or 9.19 or 9.2 milliamps to the PLC input. So let's do another example, just to make sure it's clear. So again, here's the grain silo that we had already set up. We've got a span of 370 centimeters with a range of 30 to 400. We're going to add more grain to get a height of 245 centimeters off the ground. That's our set point. We can now take the set point and calculate out that we have approximately 58% fill. So now that we know that our silo is approximately 58% full, we can calculate that into our output signals from the transducer to the input of our PLC. If it's voltage, it's pretty easy. You just got to take 58% of 10 volts and we get 5.812 volts. Current, a little more involved, but not terrible. You just got to take your 58% of your 16 milliamp span, add back in your set point or your offset of 4 milliamps, and for this instance you would end up with 13.23 milliamps for a signal that would be sent from the transducer to the input of the PLC. Let's do one more example. And this is one that sometimes gets people or catches people off guard. Again, we have a span of 370 centimeters. Let's add some more grain, but now the set point is at 370 centimeters. But as you can see by the diagram, there's still a 30 centimeter offset from the lower range limit. So a lot of people assume, oh, well, you got 370 centimeters, it must be 100% full. But it's not, because you have to consider that 30 centimeter offset. And when you do that, you realize that it's only got 340 centimeters worth of grain into it, which means it's only 91.9 or approximately 92% full, not 100%. Now carrying on to do your voltage and current outputs from the transducer to the PLC, your voltage output works out to be about 9.18 or 9.2 volts. Your current, you take 9.18% or 91.89% of your 16 milliamps, add your 4 milliamp offset, and you end up with 18.7 milliamps as an output from the transducer to the PLC if it was a current signal. So let's do a quick summary or a recap. Sometimes we have some values or an offset that's outside the usable range of whatever it is that we're trying to measure, where there may be a difference between our lower range limit and some other values. These may be temperatures, pressures, or anything that we wish to measure. Then we have our upper range limit, which would be considered 100% full. The distance or the gap between our upper range limit and our lower range limit, well, that's considered our span, or how much that our sensor actually needs to be able to measure. We can then, once we have our span, calculate what the percentage is of whatever it is that we're trying to measure, of where we are in our set point with respects to how much do we actually have. We can then take our percentage and use that to either calculate a voltage output or calculate a current output. So I hope this helps.